All right. Now, how can we evaluate an association rule, right? So we need to introduce the notions of support, confidence, and lift. So first of all, what is a support count? So if we have an item set, then its support count is just the number of transactions containing that item set. Like, I don't know, let's look, say, at milk and beer, right? So if we look at milk and beer together, milk and beer, how many item sets contain milk and beer together, right? So the first one, no, so it only contains milk. The second one does not contain either milk or beer. So the third one contains milk, but no beer, and beer, sorry, milk and beer. So it is the right one. Number 4 contains milk and beer, so correct. And number 5 contains bread, milk, but no beer, right? So out of 5 transactions, 2 contain milk and beer, right? So it means that my support count is going to be 2, right? And my if this is x, then my support without the word count, support of x is going to be my sigma, so support count, divided by the number of transactions n, and here the number of transactions is 5, so it is going to be 2 over 5. Okay, so here is another example. So this is bread and milk instead of milk and beer. So here the support is 3, so the support count is 0.6. Okay, if we have an association rule, so x implies y, then the confidence of this association rule is the support of the union of x and y divided by the support of x. Okay, so let me just note that we can multiply both, well, since S is sigma divided by n, right? So yeah, so we can so sigma is S times n, so we can multiply both numerator and denominator of this fraction by n. So let me do this. So times n here, times n here. So the support of x union y is going to be, times n is going to be just the support count of x and y divided by the support count of x. My point being is that when we compute confidence, we can use either the raw support count, the raw number of items in both x and the union of x and y, or we can use the support, which is the probability. And when you do it manually, usually it is more convenient to use the raw count, raw support count. Okay, so here is an example, right? So diapers imply beer. How many transactions are there with diapers and beer together? So diapers and beer, diapers and beer, diapers and beer, diapers and beer here, right? And 3. And how many transactions are there with just diapers? The left-hand side is just diapers. 4. So 3 over 4. So notice that if we do the support count, sorry, the confidence of beer implies diapers instead. Right, so then we still are going to have, we will still divide by, the numerator is still going to be 3, so it's beer and diapers together, but the denominator is going to be the support count of beer instead of diapers. And how many times does beer appear here? 3 times. So this could be 3, or 3 is 1. Right? So what I'm trying to say is that when you switch x and y here, you will get a different result. Okay, now what is a lift? So the lift of an association rule, X implies Y, is the support count, the support of the union divided by the product of supports. And notice that we can multiply both numerator and denominator by n square, right? So then we're going to have S X union Y times n square divided by S of X times n times S of Y times n, right? And this is going to be the raw support count of X union Y divided by the support count of just X times the support count of just Y, and everything times n. Okay, so if you want to use the raw counts to compute the lift, then you've got to multiply by n. And here is an example. So diapers imply beer. The lift of this association, the lift of this row is going to be 1.25. Note that the lift is symmetric. If you switch X and Y, you will get the same result. So the meaning of the lift is that the lift is the ratio of the observed support to the hypothetical support that we would have if X and Y were independent, right? So it kind of measures interdependence of X and Y. And it is symmetric, right? So the lift of the rule X implies Y is the same as Y implies X. So, and it kind of measures how dependent they are on each other. Well, and the goal of association rule analysis or association rule mining is to discover all rules such that the support is greater or equal than a predefined threshold, and the confidence is greater or equal than a predefined threshold, right? So, for example, we can say that, okay, we are going to look for all rules whose support is at least 0.2 and whose confidence is at least 0.9, something like this. Now, it would be interesting to find all the rules whose lift is very large, but there is no algorithm for that, right? So we can only extract all the rules whose confidence is bigger than a predefined threshold. And then out of those rules, we can measure their lift, and then we will find those whose lift is very large. So these two tasks will be solved separately, right? So first, we're going to extract frequent item sets, meaning that item sets whose support is greater or equal than the given threshold. And then we're going to generate rules. So all rules whose confidence is greater than or equal than the predefined threshold. Okay, so this is the end of part 3.